Okay everyone, I was asked by IM3 students to do a quick video on linear quadratic systems one more time. So I'm just going to do one problem really quick. Here we go. So this was problem 1 on the worksheet. And the graphs we'll do here later. There's a little bit of weird mistakes going on here, although I think I see the asymptote being plotted there. But we'll do the graph later. Let's solve this system with algebra first. Okay, so how do we do that? Well, notice how both expressions equal y, correct? Well, using substitution method, I could take negative x squared plus 2x minus 1 and set that equal to x minus 1 because they both equal y, right? So therefore they equal each other. So we're using the substitution method. Now solving this, I'm going to go ahead and minus x both sides. I want it to make a quadratic always has to equal 0 to solve it, right? So I just got rid of the x, as you can see. And at the same time, I'm going to go ahead and add 1 to both sides. That way I can make 1 minus 1 equals 0 as well. Now let's see what we end up with here. I now have negative x squared plus 2x minus x is simply 1x. 1 minus 1 is 0, equal to 0, and 0, of course, is 0. Now, what is the quickest way to solve this quadratic now is hopefully you recognize that you can factor it. Okay? And so that's what I recommend you do. Notice how both of them have an x in them. So I could factor out an x. That'll be my GCF. What's left over with negative x squared is a negative x, because if I take away 1x, there's still 1x left over there. Notice the plus. And of course, if I take away this x here, or factor it out, I have to have a 1 as a placeholder, right? So hopefully you realize that this is how you factor. And then solving it, well, what makes it 0 here, we're using the 0 property, is 0. What makes it 0 here, be careful because it is negative x. X equals 1, because negative of 1 plus 1, of course, would be 0. So we have our two answers. So now we're just going to take x equals 0, plug it in there. Y is going to be x minus 1. If x is 0, we get negative 1. So one solution is going to be x0, y negative 1. Now let's do the x equals 1 solution. So if x equals 1, then y, plugging it back in there again, equals the 1, or the x, sorry, minus 1, and 1 minus 1 is 0. Again, I plug the 1 in for the x right there. And so my second solution is going to be x1, y0. Okay? Now, to speed things along, guys, you could have, instead of factoring, so follow the blue here, guys. Instead of right here where we started to factor all this down here, okay, we could have instead done the quadratic formula. So again, notice here in blue, instead of factoring that right there, I could have done my a negative 1, b 1, c 0. Remember, if there's no number there, it's 0, right? And of course, I plugged it in the formula. Notice I get x equals 0 and 1 again. Pause the video if you need to. And from there, of course, I would just start with x equals 0, x equals 1 again, plug them into the equation there to find the same solutions again. So pause the video here if you need to. So guys, that's how you would do it graphically, or sorry, algebraically. Now with the graph, follow the yellow please. The line, of course, is easy to graph. We should know that negative 1, which is right there. I'm going to make my points really fat and big, guys. There's negative 1. And of course the slope is going to be positive 1. So everyone agree that this line here was graphed correctly. Basically, I'm just going to go up 1 over 1, up 1 over 1, right? That's my slope of positive 1. Okay, now what about graphing the quadratic, which I will do in red? I suggest you make a little table. Okay, and as you can see, we have the asymptote right here. And the way you find the asymptote is you're going to do the negative of the b. B is at positive 2 over 2 times the a, which is negative 1. You're going to get negative 2 over negative 2, which is positive 1. So the asymptote, you notice, at positive 1, x equals positive 1 is correct. But normally I taught you just put it in the middle of your table, pick a number smaller, pick a number bigger than 1, keep them in numerical order. Generally I like 5 points, but we're just going to do 3 points because really that's all we need this time. And I'm just going to proceed to plug in the numbers. So follow the green. I'm going to start by plugging the 0 in. So I'm going to have negative, I'm going to use black, actually stands out better. So I have the negative of 0 squared plus 2 times 0 minus 1. And of course that's just simply 0 plus 0 minus 1 is negative 1. And if you understand symmetry, the 2 is also going to be negative 1. And this vertex is the only thing left we need. So we're going to plug in the 1. So here we go. The negative of 1 squared plus 2 times x, which is 1, minus 1. All I did was plug in the 1 into my equation. Now negative of 1 squared, guys, is negative 1. 2 times 1 is 2 minus 1. And that is 2 minus 1, 1 minus 1 is 0. So if I just graph those 3 points, guys, you're going to see the v part of my parabola. So 1, 0, of course, is right there. Again, I'm going to make my points nice and fat. And 0, negative 1 is right there. And 2, negative 1 is right there. So as you can see, I'm going to have a parabola going down like that. That's why it was a negative x squared, right? Okay, let me clean that part up there. That negative x squared right there again implies it's going to open down. But notice, guys, if you follow the red, you could see graphically the line in the parabola cross at those 2 points. Right there is 1, 0, which of course happens to be the vertex. And right there is 0, negative 1. As you can see, it's in the table there. But both of those points do match the 2 answers we came up with algebraically. Okay? But anyways, guys, that's a quick rundown on how you do linear quadratics. You can solve it with graphing. But again, if you have a choice, I recommend just doing the algebra. Okay? So hopefully this helps. Until next time, bye.